Okay, good morning, class. At this point, we're looking at the grade 9, paper 2, November, nope, June 2015 from Livingstone High School. Okay. So let's go. First question, question 1. Calculate the value of x with the reason in each diagram below. So of course, to calculate the value of x is going to be angles on a straight line. So x plus 90 plus 40 is equal to 180. Straight line. So x equal to 180 minus 90 is 90, and 90 minus 40 is 50. So x is 50 degrees. You all agree with that? Right. We're looking at B. We know that x is equal to, what type of triangle is this? Equilateral triangle. So x is equal to 60y. So equilateral triangle. Okay. Number 1.2. Write the missing word or words only with regards to parallel lines. A pair of corresponding angles and angles are equal, so alternate. Whilst the co-interior angles adds up to 180. Another word for 180 is what? Supplementary. So 90 is complementary. When two lines intersect, the angles are equal. The vertically opposite, with the vertically opposite angles are equal. Not so, yes? Not suffice. Because, okay, that we should, yeah. Because of what it said, it's only two lines. So yes, it could. Okay. That's why they put two there to indicate that there's two things that you must write. But as you asked, yes, we would have given it to you. 1.4 for 8 marks. The question says, in the diagram below, determine the value of the missing letters A to D. State the reason for each answer. So, A is going to be 70. Why is A 70? Corresponding angles. With TU being parallel to VW. Right. Angle B. Angle B, I can go with
70 plus B.
So 70 plus B is 180. Why? It's a straight line. Angles on a straight line. So B works out to be 110 degrees. C? Okay, so this angle here and that angle is the same. So first, is that angle marked there on the diagram to be C? No. So first I must say that S or W is equal to C. I can't just go 2C plus 110. Because where are you going to get that other C from? You understand? So we must first say that 2 or W is equal to C. Why? It's angles opposite equal sides. As you can see, that side is given equally. Right, now we can say C plus C, which is 2C plus 110 is equal to 180. Why? Sum of triangles. And this triangle is RW. So 180 minus 110 is 70 divided by 2 is 35. Yes, Michael? Sorry? W or S? U is the same thing. Okay. So that is that the angle is 35 degrees. That one is 35 as well as that one is 35. What do you notice? I'm populating my diagram. Okay, I'm putting all that information on the diagram. So we got, do we need D? Yes, we still calculate D, and now you're going to calculate D. 110 plus 35 is equal to dy, exterior angle of triangle. Or I could have gone with angles in the straight line. Okay. So D is equal to 110 plus 35 degrees, and that is exterior angle of triangle, dot dot dot, and this triangle is WR. So D works out to be 140. Okay, it's a good question, eh? Easy. Sorry about that. Sometimes you must give some to get some, no? $1.5. We are told in 1.5, refer to the figure above and answer the question that follows. What is the name of the polygon A, B, C, D, E? It has five sides. Pentagon. Penta. What if all five sides was equal? Then what type of pentagon would that be? Not the equilateral pentagon, no. A regular pentagon. It is not regular. Why? Because all the angles are not the same. If they say it's regular, then that means to say all the angles and all the sides are the same. Okay, so you get a regular decagon. It's a 10-sided figure with all sides equal. A regular heptagon. So how many sides? 7. So all 7 sides and all 7 angles will have been equal. Okay.
Yes, sir.
Then they say, what is the sum of the interior angles of A? So now, it's a 5-sided figure, so we can get how many triangles out of here? 1, 2, 3 triangles out of here. So what we say is 3 times 180, which is 540. So the interior angles of the pentagon is 540. Now what if we add 1, 2, 3, 4? It's still 5. What if we add 8 sides? 1, 2, 3, 4, 5, 6. You've got 6 sides. So it's a hexagon. So how many triangles you get out of here? 4. Then 1, 2, 3, 4, and I say 4 times 180. You understand? And so on. Okay. It's 540. Then it says calculate with reason the size of angle E and F. So I'm going to calculate E. Angles on a straight line. So there's 1.5.3. So E plus 60 is equal to 180, straight line. And then E works out to be 120. Let's go with the other one. Yes? For the reason. Yes? So 1 mark there, 1 mark here. It's 4 marks. Okay? So let's work out the other one. So remember, this is now 120. So it's going to be 80 plus 150 plus F plus 120 plus 95 is equal to 540. Why? It's the interior angles of a pentagon. Okay? The interior angles of a pentagon. Go for it. Let's take photos of it. So mark from the book. Okay. So you got F is equal to 540 minus 80 minus 150 minus 120 minus 95. That gives us 95. Okay. Any confusion here? No? Just take that the calculator away here quickly. Right. We're looking at question 2. In question 2.1, we are told that in the diagram above, quadrilateral. So what's a quadrilateral? 4-sided figure. Quadrilateral AGCH has angle A equals 3x plus 20 G, which is 2x, C, 4x minus 12, and H, which is 3x minus 32. Complete the following equation. Angle A plus angle G plus angle C plus angle H adds up to 360. As you can see, you can make two triangles out of it. And 2 times 180 is 360. Okay. Now write an equation in terms of x and solve for x. So what can we say? 3x minus 32 plus 3x plus 20 plus 2x plus 4x minus 12 is equal to 360. What's the reason? Interior angles of quad adds up to 360. So it's going to be 3x, 6x, 8x, 12x. Not so? So it's 360. 360 plus 32 minus 20 plus 12. That gives us 184. Is that correct? So I divide by 12. Sorry? That's wrong. Okay, let's go again. It's 360 minus 20 plus 32 plus 12. Now what did Alan say? 384. Divided by 12. 32. Therefore x is equal to 32. Jesus. I'm allergic to something. Now I'm itching. Yes? Right. The next question is then it says determine the size of angle C in degrees. So if you look at angle C is going to be 4x minus 12. Okay? So angle C is 4x minus 12. So it's going to be 4 times, my x is 32 minus 12. So 4 times 32 minus 12 gives us 116. Is that correct? 116 degrees. Okay. Yes? 2.1.2. 2.1.3. Remember, x is now, we know what x is. X is now 32. So what I do is I replace the x with 32. Remember, that's the angle that they want here. So it's 4 times 32 minus 12, and that's how I get the size of angle C. If they ask you for angle H, it's 3 times 32 minus 32. And it's solved next. Number 2.2. We are told in 2.2.1, they ask you to calculate angle A with reason. How do you calculate angle A? We know that angle A plus 35 plus 65 equals 180. Why? Sum of triangles. And it's triangle ABC. So angle A is equal to 180 minus 100, which is 80 degrees. Okay, go to the next one. If D is a point such that ABCD is a parallelogram, if D is such that ABCD is a parallelogram, write down the size of angle D with reason. So A, B, C, D. So if this is a parallelogram, then that's what it's going to look like. And there is the D. Not so? So what would the size of angle D be? 35 degrees. Why? Opposite angles of parallelograms equal. So big D is 35. So opposite angles of parallelogram are equal. Do you understand?
Yes.
Did you go to the toilet? Why not?
Sir, let me see this.
I did.
Oh my gosh.
And I was wondering why it's smelling like that now. It's a joke, no? Nobody to phone me and ask me why. It's a joke, no? Okay. 2.3. So here in 2.3 we are told, come girls, relax. Copy and complete the table showing some collateral properties by ticking the appropriate box. Properties, we got the square, kite, parallelogram, rhombus and rectangle. For 5 marks, the question says, opposite sides are equal and parallel. That is, a square, palm, parallelogram, rhombus, right, not a kite. The angles bisect each other, which means to say that the angles cut each other in half. Square, parallelogram, rhombus, rectangle, not a kite. Why? Because the diagonals don't bisect each other in a kite. One diagonal bisects the other. But when it says here the diagonals bisect each other, it means to say both diagonals are cutting each other in half. Okay. The diagonals are perpendicular. Square, kite, and a rhombus. Those are the 3 shapes where the angles are perpendicular. Don't forget that. Very important. Often that gets asked. Okay, yes.
Do they mark like this or like this?
1, 2, 3, 4, 5, it's down. Okay. What do you do? You think got the memo of this? There's in the memo. Otherwise you got the video. You take pictures here. Yeah, must brush my teeth first. Yeah. Okay. Next one. State 4 cases of congruency. The 4 cases are what? Side, side, side. Side, angle, side. RHS. And 4 cases of congruency. Eh? Yeah, 2 marks for the first 2, 2 marks for the second. 1 mark for the first 2, 1 mark for the second. Right, next one. State whether the following pairs of triangles are congruent or not. If not, give a reason for your answer. If congruent, state the case of congruency. Right, congruent or not? Huh? Not. No. Why? You see, opposite that angle that is marked is not the same as that here. So you say the corresponding angles are not lying on the required spot, or whatever you want to say. Okay. 2 points. B. The B part says congruent or not congruent? Congruent. Why? Yes. Yes. And the case of congruency, side angle. For the side angle side case, it must be the included angle. So if x had to lie here, and this x had to lie here, then you wouldn't have been congruent. Why? Because for the side angle side, it must be the included angle. Can you see that? Must be the angle between the 2 narrow sides. Okay. So yes, it is congruent, side angle side. Next. Question 3. State whether the following are true or false. All rectangles are parallelograms. True. Are all parallelograms rectangles? No. A quadrilateral is a polygon. True. A rectangle is a special trapezium. True. A rectangle is a special trapezium. What's a trapezium? One pair of opposite sides are parallel. So if you look at a rectangle, is it not that one pair of, isn't it that the opposite sides are parallel? But the least it could be is that this is the case. So it is then a trapezium. Check the whatever I written in the answers back in the days. Let's hear. Let's see whatever I written. Check. False. Maybe then I was confused. Was it my writing? Mine. A rectangle is a special trapezium. Now I would say it's true. But I said, because the property of, because look at the first one, we say all rectangles are parallel. Look at it. So you then saying true. Why? Because in that rectangle, opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. And the angles bisect each other. So all the properties of a parallelogram you find in the rectangle. So that means to say it's true. Can you see? So if the properties is evident in the rectangle, that is why it's true. So now reading this here, a rectangle is a special trapezium. Hi.
So 9B.
8.
Just for afterwards.
Just hang on. A rectangle is a special trapezium. Yes, you can check it. I would still say true. The last one, a congruent triangle is also a similar triangle. False. Okay, so we'll go with false. But why? Why?
Only one pair of sides are parallel in a triangle.
But is that a rule not evident in a rectangle? Right, I don't know, so let's go with false then. Okay, next one. A congruent triangle, congruent triangles are also similar triangles. True. Congruent triangles are also similar. Why? Okay, same. When triangles are similar, what do we know? All the angles are equal. That's the least you can. Now we look at the congruent triangle. Is all the angles not equal? Yes, so it's true. But you see, for similarity, all the angles must be equal. Is all the angles equal in congruent triangles? Yes. So true. Okay, look at it this way. If this triangle is congruent to that triangle, not congruent, no? So they're exactly the same. Okay. So all the angles are equal. Not so. Now if that is 5, 5, 4, 4, 3, 3. So what's on the sides?
A similar triangle might have
Bigger side, small side. Right? Good. So if this is your triangle, and this was 3, 4, 5, this could have to be 6, 8, and 10. Not so. So that would be the case. So those triangles are similar. Yes. Right. So how do I move from the to 1 and multiplied by 2? How do I move from 5 to 1? 5. Times 1.
Why are we multiplying?
Because the sides are in proportion. If triangles are similar, sides are in proportion. So is all congruent triangles similar? Yes. Is all similar triangles congruent? No. So this statement is true. 100%. Why did I write the in the answers? Okay. Right, next. 3.2. Question 3.2. Didn't we do the sum yesterday?
No.
Probably with the other grade, something similar. Oh, grade 8.
Something similar in additive.
Oh, in the other test. Okay. The figure above shows a kite complete 3 blanks below to prove that triangle B EC is similar to or congruent to DEC. Yes, miss?
Your lecture is ready, sir.
Thank you, miss. That's a letter for the bride. But we're going to hand it out when the whole grade is here. Okay, which is when you all write it Tuesday. So I'll print it for Tuesday. Okay. So BE is equal to ED. Why is that the case? One diagonal bisect the other in a kite. Not so. Right. Then we're saying that CE is common side. BC is equal to adjacent sides of a kite are equal. DC. Therefore, so we use 3 sides, no? Therefore, triangle DEC is congruent to triangle BEC. Why? Side. We use 3 sides to prove this two triangles are congruent. Okay, which means to say all the angles and all the sides are also equal now. Okay. The next question says, refer to the diagram alongside, calculate BD with reason. BD with reason, and this is question 3.3. So BD, this length here. Okay. But if you look at this triangle BDC, can I calculate BD in that triangle? No. Why? Because I'm shorting BC. However, I can calculate BC in the other triangle. Not so. So in triangle ABC, what can I say? That BC squared is equal to 9 squared plus 12 squared. Why? It's Pythagoras with angle A equals 90 degrees. So that's 81 plus 144, which is 225. Check. So BC is going to be 15 units. You all agree with that? Any confusion? Yes, Michael? The reason, yes. Yeah, you will definitely use more. Right, so in this triangle, now we can work it out. So we say in triangle BCD. What can we say? You can say that 21 squared is equal to 15 squared plus BD squared or x squared, whatever. Why? Because of Pythagoras. Can I just say angle D? Safer for us to say DBC. DBC is equal to 90 degrees. So 21 squared minus 15 squared is equal to BD squared. So 21 squared minus 15 squared is 216. So what do I do now? The square root thereof will give you 6 root 6. Is that correct? Or if you press SD, 14 comma 6 9, so 14 comma 7. 14 comma 7 units. Okay. Yes? You're going to leave that angle out, you're going to lose it. You must write, if you leave Pythagoras out, then you wrote an angle in, then you would still get them out. Yeah, but you can't leave the angle out if the triangle is marked. Or named. Then in 3.4 we are told that in the diagram alongside, If you guys are talking in the background, it's making it very difficult to teach like this. There's 3.4. We are told that in the diagram alongside, triangle PQR with PR is equal to 3K plus 1, and then PQ is equal to 3K. PR is 3K minus 1, PQ is 3K plus 1, and then we are told that PR is perpendicular. So what does that mean to say? I can use Pythagoras. It says determine the length of QR in terms of K. So what do we say? That we're going to firstly say that 3K plus 1 squared is equal to 3K minus 1 squared plus RQ squared. Why? Because it's Pythagoras with angle R equals 90 degrees. You see that, people?
Yes.
So that is going to give us, you must write it out twice, so it's 3K plus 1 times 3K plus 1 is equal to 3K minus 1 times 3K minus 1 plus RQ squared. So I'm going to get rid of the brackets first. So it's going to give you 9K squared plus 3K plus 3K plus 1 equals 9K squared minus 3K minus 3K plus 1 plus RQ squared. So what I'm going to do is I'm going to get RQ squared on its own first. So what I'm going to do is I'm going to take everything over the equal sign. So that means to say that 9K squared plus 3K plus 3K plus 1 minus 9K squared plus 3K plus 3K minus 1 is equal to RQ squared. Okay? Which now can cancel, simplify. So 9K squared cancels 9K squared, 1 cancels 1. So RQ squared is equal to 3K plus 3K plus 3K plus 3K is 12K. Then you get the square root of that. So RQ is equal to the square root of 12K. Okay? Let's check if that's correct. Right, yes. Next question. We are told that the triangle in the following, the triangles in the following figures are congruent. Take triangle ABD as the first triangle in each question and name the second triangle in the order of congruency. Write each of the write the case of congruency in brackets as shown in 4.1.1. Okay, so triangle ABD is congruent to triangle. So angle A is equal to which angle? Is equal to angle E. As you can see, it's alternative. Can you see? Then we know that this angle is equal to that one. It's vertically opposite. And then of course angle B is equal to angle C, the third angle of the triangle, or alternate angles. So angle A is equal to which angle? Angle E. Can you see that? Angle B is equal to angle C. And angle D is of course equal to D. So triangle ABD is congruent to triangle ECD. Why? We used but these lengths are also equal. So yes, our order is right. So what case of congruency is this? We use two angles and a side. So it's angle, angle, side. Don't forget that when we use congruency, we must use at least a side. Yes?
So if I say it's equal to triangle CDE.
CDE, then you will lose them all. Because your order is not right. You see, when you look at angle A, you see here, angle A must correspond with that angle here. So you see that triangle ABD is congruent to triangle CED. CDE. So that means to say that your angle A is equal to your angle C. Is angle A equal to angle C? No. So you will get them. You will lose that mark. And if you lose that mark, you can't get this mark. Why? Because in geometry, if your statement is wrong, you can't get a reason mark. Yeah. So watch out for that. Okay. Let's look at 4 point. Okay. Let's look at 4.2.2. So we start with triangle A, B, D. It's congruent to triangle. So you go. A is congruent to triangle. Which angle is that equal to? The angle D. Can you see again alternate? Okay, that length is equal to that length. That is given. And that is equal there. Not so? Right, so there's A, B, D. No parallel. Absolutely correct. Is that right? No. This here, this length. A, D is a common side. So what case of congruency is this? Side, angle, side. So the case of congruency is side, angle, side. Right. So angle A must be to which angle? Angle D. So you start off with A and D. Then we move down. So of course this angle here and that angle will be. Not so. So it's going to be, it goes A, B. So B would correspond to which angle? S. So it's D, S, A. And we can check if we are correct. AB should be equal to DS. AB is equal to DS, and that is the case. Can you see that? DB is equal to SA. DB is equal to SA, yes. And AD is equal to DA. Yeah, that is your common side. Can you see? So that is why the order is important. Okay. Just hang on. So let's just wrap this up quickly. Hang on. Right, so this is triangle. This is wrap this up quickly. ABD. ABD is congruent to triangle. So ABD is congruent to triangle ACD. Why? You use the hypotenuse and the 90. Can you see that?
Yes.
So that is RHS. Okay. 4.1.4. So it's again triangle ABD is congruent to triangle. So ABD is congruent to triangle CBD. And what case of congruence is that? We use side, and this side. Okay. Yes, you can't use angle. Okay. The last question quickly. You are given, determine the angle C. So angle C is going to be 180 minus 85 minus 35. Work that out. Should get an answer of 60 degrees. Why? Sum of triangles, and it's triangle ABC. So that's 60. So what do you notice now? If you work out D will be 85. Okay. Then the next question says, it should be a similarity. You must give a reason why. Why is triangle ABC congruent, similar to triangle DEF? Because not side. Angle. Then it says calculate, and of course you're going to get a distance question following this. So in 4.2.3, we know that AB over DE should be equal to BC over EF.
Your attention please. All learners and staff who are
AC
dressed in green can
over
please go to the quad area.
Why?
All
Because the two
learners and
triangles
staff
are
who
congruent.
are dressed in green
Normally in
please
line,
go to
triangle
the
we can
quad
say
area for photograph.
the corresponding sides are equal. So AB is unknown. Can you see that? Over DE, 6.5 equals AB, sorry, DC, BC is 3 over DE, EF, sorry, 7.5 equals AC, which is 1.7 over DF. So the question was to calculate those two unknown letters, unknown variables, which is AB. So I'm going to use that because we know those two values. So cross multiply. So 7.5 times AB, 7.5 AB equals 6.5 times 3. So I divide by 7.5 both sides. So AB works out. Somebody work it out. On the other hand, we're going to say those two equal. So it's 3 over 7.5 equals 1.7 over DF. Cross multiply. So it's 3 DF equals 1.7 times 7.5. Divided by 3. So DF is equal to what here? I think that was a bit rude, no? Whoever that was. Was that you? Didn't expect that from you, Michael. No? I think better of you at least. This answer here is what? 2.6 centimeters, and this one here? That cancels. 1.7 times 7.5 over 3. 17 over 4 or 4.25. Okay. Any confusion there? That basically brings us to the end of our revision session. People, all the best for the exams. You guys must go to Miss Dixon's room. She's waiting for you guys, no? Yeah.